Hi there, welcome back to the DevO. I am Roman and this is the fourth episode of our event sourcing do-it-yourself video series. In the last episode, we were talking about how to get the information out of the event stream, and we used projections for this. But what we are still missing is the behavior of our application. So let's implement this and los geht's. So as I just said, we used projections in the last episode, so I hope to have you convinced for now that we need events, an event store, and projections. But the big question is, where is the business logic in our nice little program? And this is what we're going to implement now. The question is, how can we actually implement it? And of course, there are many different possibilities. So for example, we could build a full-blown message-based system and implement commands and command handlers. But in this video series, I want to go a different way. I don't want to blow it up too much, and I try to implement it in an easy way that does not need to introduce too many new concepts. So for now, we are going to implement something that I call an event producer. This is an idea I took from one of my colleagues, and I think it's a pretty nice idea to implement in a simple event source system. So what is an event producer? An event producer is a function, and this function takes as an input parameter the history of all the events, so the complete event stream. And then it is doing something in there, so it's a black box for us. And in the end, it outputs a list of new events. So we have a function that takes a list of events, the whole history, it calculates something, and in the end, it produces a list of new events. So in order to be able to do this, we actually need to change the type of our event store. If we would use something like commands, we would not need to actually do this, but in our approach, we need to change the type of the event store. So we scratch this and we introduce an event producer, a new type called event producer. So this is exactly what I've just described to you. It's a function that takes some lists of events, in here parameterized, and it returns a new list of different new events of the same type. And if we want to actually use this, we want to actually evolve our event stream. And therefore, I added a new function to our interface of an event store, which is the evolve function. And this evolve function takes an input parameter, which is an actual event producer. So the input parameter is in itself a function. And it returns nothing because the events that are returned by the event producer are actually then appended to the stream of all the events. To make it a bit more clear, let's go back to the diagram of the mailbox processor or the agent and actually draw what is going to happen in there. Alright, this was our old diagram of our actor and in fact our event store. So what do we have now? So first of all, let's move this here a bit to the side so we have some more space to actually work with it. And then now our event store has another function which is called evolve. And evolve takes an event producer and returns nothing. Our event producer looks like this. So it's a function that takes a list of events and it returns a list of new events. So how would it look like in here? So we had a new message by our first client, and this message is called then evolve. And in here, the event producer is already given within the message. So now we have here this event producer. And this event producer is a function somewhere here defined in our domain. And in here we have a small function which is our event producer. And this for us, for the event store, is a black box. So the actor now calls this black box, and as the input, it takes its current state, the current history, and feeds them into the black box, which is the event producer that was given by the message. And then the black box is calculating something, and the output is a new event list. For example, a list of event 4 and event 5. So what the agent is doing now is that it actually appends the new events to its current state, so it evolved the event stream. Et voila, that's how our new evolve function is going to work. Alright, so let's actually implement this now. We want to get rid of all those event store append calls, because there might be some logic in here. So we say we restocked vanilla with 3 portions, and then we sold 3, and then the flavor went out of stock vanilla. But nothing stops us from just having a new flavor sold strawberry event in here. And when we run this, we see that we also sold a strawberry, obviously. So our projection says this, and in our event stream we see that we actually sold 1 strawberry. And of course this should not be possible, because when we haven't restocked the flavor, we should not be allowed to actually sell the specific flavor. So let's implement the first part of our domain logic. The first thing we need to do is to actually create the type event producer we were talking about all the time. So it's an event producer for some generic event, and an event producer is a function from a list of events to a list of the same event type. And now we can actually use this event producer in here and give our agent a new function to work with. So what we could do here is we could say, now we use this evolve message I was talking about, and this evolve message just gets an event producer for the events we are actually working with. And if we do this, we see the squiggle now here that we haven't pattern matched for all the possible messages. So let's just create this match here and say we use evolve, and we get an event producer out of it. And when we have done this, we could actually use this event producer to produce new events. And these new events are produced by the event producer when we actually call the function which takes a list of events, which is just our history. So we take the full event stream and give it to the event producer. So now here we can then concatenate our current history with the new events. And of course we need to call our recursive loop function again not to stop the agent, and we actually need to return our async block. Cool. So now we have created new events with the help of the event producer that was wrapped in the evolve message, and we appended it to our event stream. So in fact, we evolved our event stream. So now let's fix our event store type, our interface here, and give it a new function called evolve, which takes an event producer as its input for the events we are working with, and it returns nothing, or unit. Cool. Now we are red down here, of course, because we are not fulfilling the interface anymore. So we could just create an evolve function here, and this one takes an event producer. In here we call the agent post method with the evolve message, and as a parameter we just supply the event producer. And now we can say, okay, evolve equals evolve, because evolve is a function that takes an event producer and returns unit, and that matches exactly what we expected from our interface. Great. Now let's actually implement it. So first of all, what I always like to do first is think about the API. So we don't want this append function anymore. We didn't delete it, but we don't want to call it anymore because we want to call our business logic. So what we actually want to do now is we want to call event store.evolve. And in here, we need to give it an event producer. What could be a good event producer? We could create a function that sells a specific flavor. So we had a function sell flavor, and we need to tell it which flavor we want to sell, and this could be, for example, vanilla. And I think the best way would be to create a new module called Behaviour, and in here we could define a function sell flavor, and this function gets a flavor. And then we could, for example, just say that we sold a flavor, and it's not open here, so we open the domain module where all the types reside, and it's called flavor sold, and we have sold our flavor. So it takes a flavor and it returns an event list. And now we could say here that we have the behavior dot sell flavor. But this is not working. Why? Because the evolve function actually needs as a parameter an event producer, which is a function that takes a list of events. And this sell flavor is not doing this. This sell flavor actually just returns a list of events. But the nice thing about F# is that all functions are carried by default, so we can use partial applications everywhere. If you have no clue what partial application actually is, you can go back to my F# introductory series and check out the video about partial application currying and so on, and why I think it's pretty useful. And here you have a good case for partial application. So what we actually want sell flavor to look like is that it's a function that takes a flavor and it takes a list of events and then it returns another list of events. So down there we partially apply the flavor to the sell flavor function, which means that now sell flavor is not a function with two parameters anymore, but flavor is already applied, so it returns a new function that takes the events and returns a list of events. Nice. And now this is working here. So we could also evolve it with the strawberry. And when we save this and actually run this, we see that we haven't changed too much actually. We have sold a vanilla flavor and we have sold a strawberry flavor. And our projections tell us the same. So we are only one step closer to actually have real behavior in our application, but now we actually need to implement the behavior in our application, because for now our sell flavor function does not do anything except of returning a list of sold flavors. So it does not use the events that the actor or the agent or our event store is actually supplying to it. So let's do this. What do we want to do? We want to somehow get the stock for a specific flavor, and then we want to check constraints for flavor sold, which means we want to somehow get the stock out of our event stream for the flavor, for example vanilla, and then we want to check if we can actually sell this flavor because the stock is big enough in there. So we somehow need to take this thing here and say stock, and we just start with a 0. And to check the constraints, we could pattern match over the stock and could say if it is 0, we should return that the flavor was not in stock that we were trying to sell. If the stock was 1, what do we actually want to return? We want to return that we've sold the flavor, but it was 1, so now it is 0. So we can actually use the case that we are returning an event list here and say that the flavor went out of stock. And in all our cases, we expect that we had enough stock, or the stock was big enough, so we could just say that we sold this specific flavor. So if we call this here again, we get that the flavor was not in stock for vanilla and strawberry, because we always said that the stock is 0, and our behavior tells us that then we need to get this event flavor was not in stock. So how do we get the stock now? Well, what do we have? Let's just make this clear. We have a list of events, and we somehow need to get the information out of the list of those events. So how do we do this? Well, if you think back to the last episode, we need to use projections for this. So we could also use projections in here in our behavior. We just project into the data structure we need to work with, and then we can actually get the information out of the event stream. So let's do this. Let's open the projections here. And then we could actually try to get the stock by using our events and project them into a new, or with a new projection, that we need to define. So let's call this stock of flavor. So we need to define this projection now. How should it look like? I think it's pretty similar to the sold flavors. We could use a map here as well. We could use a map from a flavor to an integer. So then if we use this stock of flavor projection here, we would get back a map from a flavor to an int and see how big the stock in general is. So let's do this. We could actually copy paste this here because it's so similar. And we use the name stock of flavor for this projection, so it's also a projection that has the map from flavor to int as its state, and it also takes our events, of course. Then we could introduce a new update function, which is called update stock of flavor. Thinking about it, maybe stock of flavor is not the best name. Let's call it flavors in stock, and we call also the update function flavors in stock, and also we could call this down here like this. Okay, when we update the flavors in stock, what do we have? We have a new function, of course, and if we have a look up here, the update function always get the current state and one event. So let's do the same here, and maybe we could also call the state the stock, because that's what we are talking about. And then we can actually again pattern match over the events. So we start with all the events, we just return the current stock, and now we can actually think of which events actually change the stock. So the most important one now, because we are working on this, is the flavor sold event. So if the flavor sold event was emitted by our event producer, the stock needs to decrement. To speed things up a bit, I've already prepared this little thing and paste this in here. What we're doing here now is that we're trying to find in our current stock, which is a map of a flavor to int, the flavor, and if we find it, we use the value out of it, the portions, and update the value in our map with -1. So we say portions -1, because when we have sold one flavor, we need to decrement it by 1. Now we have our projection here, but we see here that we still get a red squiggle, because stock is now not a integer, which we are thinking that it is, but it's a map from flavor to int. So let's build a new helper function, stock of, and we get it a flavor and the current stock. And then we say, let's use the stock and say map, try find the current flavor, and now the function returns an option, and we don't want an option, so we just say again option.default value 0. So if we don't find the current flavor in our current stock, we just assume that the stock is 0. And then we can just say down here stock of flavor, and now we have the first function in our system that has actually behavior in there. So let's go over it again. We have our events and we want to sell one specific flavor. We use our events to project the flavors in stock projection, and we get out a map from a flavor to an integer. Then we use our stock of helper function that tries to find the current stock for a specific flavor, and if it's not finding it, it just returns 0. Then we match over the value, and in case it is 0, we emit a flavor was not in stock event. If it was 1, we can actually sell the flavor, and we emit a flavor went out of stock event, and in all other cases we say that the flavor was sold. Nice. I think now we should call our program again. And as you can see, we still get the flavor was not in stock vanilla, and the flavor was not in stock strawberry events, because we have never actually restocked our stock of flavors. We only tried to sell flavors without ever restocking them. So talking so much about restocking, let's just implement restocking. So what we want to do now is that we want to call a function restock, for example, for vanilla with 3 portions. So this is what we want to do now, and then we expect that afterwards we can actually sell our flavor vanilla. So we are here in our behavior, and we are building the restock function. And here we don't put any business logic in here up to now. We just say that the flavor restocked, the number is missing here, and we say flavor, and number. And now we have a restock function that takes a flavor, takes a number, and emits the event flavor restocked for the flavor and the number. But again, just to make sure that you got the thing with the event producer, this is not working, because what we actually need to provide to the evolve function is an event producer, which is a function that takes a list of events and returns a list of events. So again, we use partial application for this and say that this function actually also get a list of events in here, and then we have our event producer, which is pretty nice. So that's it. No, of course not. Because, as I said up here in the projection for the flavors in stock, we need to cope with all the events that are actually working on the stock. And now we have also the flavor restocked event, which is also obviously working on a stock. So we need to use it in our projection function. And here we have a flavor and a number. And then we can reuse this code here because it's pretty much the same. So we can just copy paste this. So now that we have reused it, we actually need to change the decrement part, because when we restock, we actually want to increment it by the number that we have provided in the event. And now, to not repeat ourselves too much, we can extract the function down here, and we call the function restock. And this function needs the flavor, it needs the number, and it also needs the stock. And then we can actually use the same code. And I put the stock as the last parameter because then we can use it in a pipe and say restock the flavor for the given number. We put our stock into the restock function for the flavor and the given number. And in here we can use the same. So we could also say stock restock for the flavor, and here, because we always decrement by 1, we could just put in there -1. So now when we call the restock function, because of the flavor sold event, we get a -1 for the number or for the portions, and then it's plus -1, and this is decrementing. Really nice. So we put in quite a lot of business logic in there, and I think everything should work now, which would be pretty cool. What do we expect now? We expect that we get a flavor was not in stock event for the vanilla, a flavor was not in stock event for the strawberry, then a flavor was restocked event with portion 3 for vanilla, and when we sell then the vanilla, we expect that we get a flavor sold event. So let's do this, and then we can finish up this episode. This does not look so good, because we have the flavor was not in stock, which is alright. We have the flavor was not in stock, which is also alright. And then we have the flavor restock, but then we actually expect a flavor sold event. And also here we see that the sold vanilla is still 0. But just for debugging purposes, we could use our projection that we have defined up there and print it out as well. So if we get the stock by using the events and project this in our new flavors in stock projection, and then we use another helper function, which is called print stock of flavor instead of print sold flavor, we should see that the stock of vanilla is 1. So let's check this, comment those out. We see that the stock of the vanilla is 0. Which means we might have a bug in our projection. So, what did we do wrong? Well, something was wrong with the projection, of course. And if you remember correctly, I just copy-pasted the code in there. And I said, just speed things up. And this is how a project normally works, right? We just copy-paste something here, we think something works, and in the end, it does not. But what was our actual mistake in here? We didn't have any tests. So if we had some tests in there, we would have recognized this mistake or this error much earlier. So this is what we're going to do in the next episode. We're not only going to fix the bug that we have just implemented, we're also going to write tests for our behavior, for our business logic, to be sure that these bugs won't ever happen again. So I hope to see you in the next episode. Please feel free to contact me if you have any questions. See you in the next episode. Bye bye.